Good afternoon, students. Can you see the screen? Can you hear me? Gabby? Abigail?
Yes, sir.
All right, good, 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 good. All right. So I just want us to go through this classwork that we did, and then I want to do some of the questions that I sent for you guys to do. All right. So I'm gonna start with number one here, and in number one, we're given these points: A, B, and C. O is the origin, and then we're asked to write the position vectors for each of these. And when you're writing position vectors from coordinates, it's just a matter of writing back the same values in the column vector form. Simple as that. So for part 1, A is the point minus 1, 3, and so the position vector of AOA has the same values minus 1, 3, no calculation needed. B is a point minus 5, 4, and so the position vector of BOB has the same values minus 5, 4 in the column vector format. C is a point 7P, and so OC, the position vector of C, is 7P in that format. And that answers part A, right? For the position vector of A, B, and C. Then part B wants us to work out these two displacement vectors, BA and AC. Well, AC is going to be found in terms of P, meaning P must be in the answer, right? Because P is a part of the vector OC over here. Alright, so first one, BA, displacement vector BA. Now, since we know the position vector of the B and the position vector of the A, we can use O times the last minus O times the first. B is the first, A is the last. And so it's O times the last, which is OA, minus O times the first, OB. And so it becomes OA, which is this one, minus 1, 3, minus OB, which is this one, minus 5, 4. And then we will do the calculation. This minus minus becomes a plus, so that's like a plus 5. So it's like 5 minus 1. 5 minus 1 is 4. And then this is 3 minus 4. 3 minus 4 is negative 1. And that is it. That is your vector BA. Simple as that. That's an answer right here. And then we want the vector AC. So using a similar approach, the vector AC, since we know the position vector of the C and the position vector of the A, we can use OC minus OA. O times the last minus O times the first. Now OC is 7P minus OA is negative 1, 3. Right, that's what we have here. 7P minus 1, 3. And so calculating now, again, this minus minus is a plus. And so 7 plus 1 is 8. And then P minus 3 are unlike terms, so it comes back P minus 3. And that is your vector AC. Alright, so AC is this vector. Again, that's an answer right there. Alright, that's part 2 of B. Then we'll come to part C, which tells us that the modulus of AC is actually equal to 10. And so modulus of this vector is equal to 10. So in part C, we're told that the modulus of the vector AC is actually equal to 10. Modulus would be the length of this vector. The length of that vector is the square root of this value squared and this value squared. Remember, it comes from Pythagoras' theorem. Remember, this vector means really means that to go from A to C, you go 8 units to the right. So this length to be 8. This length to be 8. And then P minus 3 units upwards. P minus 3 units upwards. Alright? P minus 3 units upwards. So this will be P minus 3. That's a right angle triangle. And you're trying to find the length of this vector. And so it's Pythagoras' theorem. It becomes the square root of this side squared plus that side squared. That gives the length of this side AC. Alright? And that is the concept. And they're telling us that this length is 10. Alright? That length is actually 10. So the square root of this is equal to 10. Alright? The modulus is equal to 10. And so we're solving this equation now for the P. Alright? So how do we solve this for the P? We're going to move the square root by squaring both sides. So if we square both sides, square this side, and square this side to get rid of that square root. And then we can square this 64. Now remember, the square root is going to be eliminated. The square root sign is eliminated with the square. But then this 8 squared remains, that is 64. This remains P minus 3, I need a square on this. This remains P minus 3 squared equals, and then 10 squared is 100. So subtract the 64 here, we get P minus 3 squared equals 36, because 100 minus 64 is 36. Then to get rid of this square, we have to square root both sides. Square root this side and square root that side. And this square root eliminates that square. Right? But then when we calculate square root, remember it can be plus or minus. I'm going to put a plus or minus here. Plus or minus. Right? Because a positive number squared and the same number when it's negative squared gives the same result. So for example, negative 6 squared and positive 6 squared, both of them equals 36. And so the square root of 36 can be plus or minus 6. Plus or minus 6. So then this P minus 3 becomes equal to plus or minus 6. And to leave P as a subject, we can transpose this negative 3 over here, make it positive, and P becomes 3 plus or minus 6. So P equals 3 plus 6 first, that's the first value, which is 9. Or P is 3 minus 6. 3 minus 6 is negative 3. And those are the two possible values of P. That will make the modulus equal to 10. Alright? Then now, the next part introduces a point D such that the portion vector is 11, 0. So, D is a point such that the portion vector is 11, 0. So, they're giving us in part D that OD is 11, 0. And this part wants us to use a vectors method to prove that the points A, B, and D are collinear. A, B, and D. So if we're using A, B, and D, we cannot use any vector with C in it. So what we need is two vectors between those 3 points. Right? So for part D, we're doing A, B, and D collinear. So we're trying to prove. Now to prove collinearity, we need to show that we have parallel vectors between between those 3 points. Two parallel vectors between those 3 points. And there will also be a common point. So parallel vectors with a common point is what we need for collinearity. So we're searching for two vectors between these 3 points. We have one already. We have a vector between A and B up here. So it's BA, this one. 4, negative 1. So that's one of the vectors I'm going to use. We don't have to form another vector there. So BA is 4, negative 1. And I need another vector. So I need another vector that includes the D. So it's either AD or BD. Doesn't really matter which one it is. Any one of them will work. Alright? Doesn't really matter. So let me put this and over here. So let's say I'm going to use AD for no particular reason. I'm just going to use AD. I'm just going to use AD this time, because I'm working with numbers. So AD will be equal to OD minus OA. O times the last minus O times the first. The OD is 11, 0 minus the OA is negative 1, 3. And when we do this calculation, the minus 3 again is a plus. It's like 11 plus 1 is 12. And then 0 minus 3 is negative 3. And that is your AD. And with these numbers, it is clear that you have to multiply this one. You have to multiply this one by 3 for it to become equal to that. Right? And so you can therefore say this big one is 3 times the small one. 3 times the small one. Or if you follow the process that we did in class, we want to make these two things equal, these two sides, we want to equate them, we want those two sides to become equal. So the process of showing that these two vectors are parallel is to bring them to a state where we can equate and show one as a multiple of the next. I want to show that this one is a multiple of that one, or vice versa. And the process says, first step is to get rid of any fractions, because fractions make it difficult to see the relationship between the numbers. Alright, the multiplier relationship between the numbers. But there are no fractions here. The second step is to multiply the smaller vector by a number that will make it equal to the larger vector. So this is a smaller one. And we can see that if we multiply this one by 3, it becomes equal to that. And so what we do, we multiply this whole equation by 3. So I'm going to multiply the whole equation by 3. We multiply that whole equation by 3. This equation becomes 3ba. Because you have to multiply this side by 3 as well. You multiply this by 3, it becomes 12 negative 3. 12 negative 3. And so we're now comparing these two. This one and this one. Two of them equal the same thing. And therefore we can equate this and this, which is what we do. So our next step is to equate. Right? Now this step was not needed here because the numbers are friendly. Right? We say that the big one is 3 times the small one. But if we're going through the process, we'd have to equate at this step. And so we could say this one AD is equal to 3BA, because both of them equal 12 negative 3. So that's equal to 3BA. And so we have what we need in this step, this line. What does that mean here? We have the two conditions for collinearity. One, because one vector is a multiple of the next. That's the first thing. The vectors are parallel. So we can say AD is parallel to BA. That's the first thing that you must have for collinear points. The second thing is that you must have a common point, and in this one, A will be the common point for this one. And so we're going to write that A is a common point. And then because these two conditions hold, because you have those two conditions, you can say therefore 3 points involved, A, B, and D, are collinear. Alright, are collinear, and that's a proof. Now instead of using the AD, we could have used the BD. Right? We could have used the BD. And if I just work out the BD and show you what would happen quickly, if I use the BD instead, it will be OD minus OB. And the OD will be 11, 0, minus the OB was minus 5, 4. And what that means that this minus 1 is a plus again. 11 plus 5 is 16. 0 minus 4 is negative 4. That will be a BA. And all that, this is now 4 times the BA. Oh, this is BD, sorry. This is BD, not BA. This is BD. We can clearly say that this is 4 times now the BA. Remember, the BA is this, and the BA is this. The BA is 4 negative 1. So for this to become equal to that one, you have to multiply this one by 4. Alright? Which means that this large one is 4 times this small one. You have to multiply by 4 for them to become equal. And so in this case, you would have BD equals 4 times BA, which then B will be a common point, and again you'd have parallel vectors with a common point. So you could have used BD instead. Alright, and that finished that first question. Everybody alright? Everybody good? I'm just here talking and not hearing any response.
Yes, sir.
Thanks. The second question was a very easy question, and a lot of persons realized after working and doing more than was needed how easy it was. Alright? And I hope you learn from your mistakes and you learn from that. Alright? Because we're trying to do far more than we needed to in this question, some persons. Alright? So this question, it gives us a diagram, that's a vector diagram, it's a parallelogram, and I like parallelogram questions because it means that you know some of the sides, right off the bat. So this question says, the diagram below not drawn to scale, it shows a parallelogram, good, alright, and O is the origin. It says the point S is on Kn such that Ms is 2 times Ks. So this is information for us to break down this line into fractions or into portions or parts, right? So the ms here has 2 of this in it, 2sk. So if we were to write it on it, make the pen a little thinner. This side is 2sk, that's what they said. Ms is 2sk. So this side is 2sk. And this side is clearly just 1sk. Right? Now if we focus on the numbers and take off the sk, is that this side is 2 parts to 1 part. 2 equal parts to 1. So the total parts on this line across MK is 3. 2 plus 1. So in terms of a fraction, this part, M to S, is 2/3 of the entire line. And S to K is 1/3. 1/3 of the entire line. Alright? So S divides this line 2/3 and 1/3. Alright? So that's what we know. But I can just leave the 2 and the 1 on it for now. And that will remind me, this is 2 parts, 1 part of the line. 2 to 1. Alright? They could have given the ratio. They could have given information and say MS to SK is 2 to 1. They could have given information that way as well. Alright, what else did they say? It says the vector OK is V. That's this vector across here is V. Now, I'm going to populate the diagram. Since this vector is V, right, that direction on that line, that length, and this line has the same direction, parallel, and the same length, it means that that vector from M to L is also V. Right? So you can put that on the diagram. This vector is also V. And then similarly, they say that this vector OM is U. Right? They said OM is the vector U. So again, these two sides now are parallel and equal in length. So if this vector is U, then the vector going up this way is also U. Let's go to the populated diagram. So this vector up here, going up here, is also U. Right? And so remember, I said in the class that vectors at this level is really more about how you go around this diagram from point to point. Think of it that way. And these are like pathways that you can use. So like you have 4 pathways now that you already know that you can use. Right? But any path, even inclusive of multiple stops between 2 points, will give you the same resultant vector. Right? Give you the same resultant vector. So the pathway that we don't yet have an expression for is this one. And we also don't have an expression for this one. Right? Those are 2 pathways that we don't have. Now, I did say in the class that you should to do MK first. Alright? There was a method that we could use and use OS first, but I deliberately wanted to find MK first. And MK is quite obvious on the diagram. It's how do you go from here to here. Remember, you cannot come across here right now because you don't know that pathway. The pathways, you know this one, you know this one, you know this one, you know this one. And you don't have to come across here to go from M to K. Right? You can go out here first to L and then go from L to K this way. Alright, now looking at the diagram, that is the preferred path for me because you'll be starting in the positive direction of this vector. So I would say to go from M to K, I'm going to go M to L first. M to L first. And then the plus means and then I'm going to go L to K. And it shows the M to K is just V, and the L to K is a negative U. Now, why is it a negative U? Because you're going in the opposite direction to that U. So this direction is minus U. Alright? So, and that vector is minus U. So it's V minus U. That is it. I could just look at the diagram and see it's V minus U using this and this from the diagram straight without having to write this out. Alright? So in any case, it is V minus U. That's vector. That's the vector MK. Now, the third process I keep saying in the class, guys, is that now that you know MK, you have to think now as if you can now travel a lot across here using this vector, because you now know it. Now you can travel across there a fraction of the way. For example, you can go to M to S if you want, using 2/3 of the MK, or you can travel S to K using 1/3 of the MK. Because you know it's almost like you know this road. Right? You know the vector down here. You can use this whole vector if you want to go the whole way, or a fraction of it. But the bottom line now is that you can travel along this side using this vector. Think of it that way. Alright? So the question is we're gonna encounter a question that is asking us to travel along this side now. Alright? So the second question that I wanted you to do was SL. The vector SL. The vector SL is from here to here. We can't go across here, guys, because we don't know that road. We don't know it. We don't know anything about this road right now as yet. Right? So look at another way to go from S to L. To go from S to L, we can come down to K first here, and then go from K up to L. It's one way. Or we can go back up to M this way, and then go across here. Now, any one of the ways you choose to do it, the results are going to be the same. You know? If you decide to come down here, then go back here, then go up here, then go across here, the answer is going to be the same. Right? If you decide to starting at S to reach L, right? Starting at S and want to reach L, you can't come across here because we don't know that road. If you decide to come up here first and then come down here for whatever reason and then come across here and then go up here, the answer is going to be the same. But I think the easiest path to go from S to L is to come down here first. And why would I prefer to come down here? Because I'm going in the same direction as this vector that I know. And it's a fraction of that vector that I'll be using. 1/3 of it actually. Right? The vector down here would be 1/3 of this whole vector coming down here. Alright? And then after I get to K, I would just use the U and just come up to the L. Alright? So I can write out a vector equation, right, to show the work. So for part 2, we could say to go from from S to L. We can go from S to K first, and then go from K to L. That's the easiest way. I can go back this way, as I said, opposite direction, up here, as I said, but I'd have to introduce a negative of this vector, negative 2/3, because I'm going the opposite direction. Right? So I prefer to do it this way. Now this SK, which is right here, is just 1/3 of the MK. I want to write it as that. SK is just 1/3 of the MK that we know. This is the MK, taking 1/3 of that. Plus, and this KL is just this side, right? Going up. So we can literally now just put that in if we want. That's a U. What is 1/3 of MK? This is MK, you know. So 1/3 of MK is going to be 1/3 of this part and 1/3 of this part. So it becomes 1/3 of the V, and then minus 1/3 U, and you're adding back this U. And so we are basically at the answer, but we want to consolidate these vector components So this is the only V term in there. So I'm going to put that back first, 1/3 V. And then this one now, I have to add them and make them into one U term. That's a whole U minus 1/3 U. So a whole minus 1/3 is 2/3. You have to be able to, calculate in these simple numbers. A whole minus a third is 2/3. This is plus 2/3 U. And that is how we'll go from S to L. S to L. And the beauty about vectors now, we can check if this answer makes sense on the diagram. Right? Let's check if going from S to L, we go 1/3 of a V and 2/3 of a U. So starting here, this will be an entire V across here, just like this. But this is saying go 1/3 of a V. So starting here, this looks like 1/3 of a V in real. Right? Because a whole V be all of that. So this really looks like 1/3 of a V. And when we get to here now, we need 2/3 of a U. From here to here, really looks like 2/3 of a U. Because the whole thing up here says U. So this little piece right here looks like 2/3 of a U, and you're going in the same direction as a U. That's why it's a plus 2/3 of a U. Some persons did the calculation over here and got a minus. Right down here, so I got a minus. I got a minus. If I was testing the diagram, when I do the 2/3, the 1/3 is V, and it takes me to here. 1/3 V takes me to here. If I'm doing the minus 2/3 U, the minus 2/3 U will be sending me this way. Minus 2/3 U will be sending me that way. But that will be taking me away from L. And so you would know that the minus 2/3 U don't make any sense. Right? Because it's taking me away from the L. And you have to learn to pick up any mistakes that way. And don't just accept anything that you get. Because sometimes you make mistakes, especially with your positives and your negatives. So with a plus right here, everything is good. Alright? 1/3 of a V plus 2/3 of a U takes us from S to L. The diagram shows that. Alright? That finishes that part. The last part now was for you to calculate OS. There are multiple ways to do it, but as I said, when you can't use O time the last minus O time the first time of a diagram, use a diagram. Now, to go from O to S, right? Let me put a different color on the diagram, blue. So I have two options. I can come out here to K and then go from K to S up here. If I do it that way again, I'll be going in the opposite direction to this vector that I know. Alright? I don't want to go in the opposite direction. So that can work, that direction that I'm showing now on the diagram can work, But I think it is easier to maintain the same direction as this vector, so we'll have to be introducing a negative and run the risk of making a mistake. So going from O to S using another pathway, we'll be come up to M first using this U vector, and then come down here using 2/3 of the MK. Simple as that. I believe this is the easier way to do it, because you don't have to be introducing any negative for opposite direction. So that's the way I would prefer to do it. Going from O to S is the same as going from O to M first, and then going from M to S. Now the O to S right here is just U. Plus the MS is 2/3. This MS is 2/3 of the full MK. Right? So this will be 2/3 of the MK that we found at the beginning. So that will be a whole U, and then 2/3 of MK would be 2/3 of this. So 2/3 of that side and 2/3 of that side. So this will be 2/3 V minus 2/3 U. And then now these are the two U values in there. This is the only V value in there, so I'm going to write that back first. 2/3 V, and then a whole U minus 2/3 U give you 1/3. A whole minus 2/3 of the same thing is 1/3. I'm going to put plus 1/3 U and VU. And again, I can test this answer to make sense on the diagram, because it's saying to go from O to S, I must go 2/3 of a V and then 1/3 of a u. Let's put that part in purple again. So starting here, 2/3 of a v first. The 2/3 of a v is going to take me about out here, so. So come out here, so. 1, 2, if I divide it up in 3 equal parts, this is about 2/3 of a whole v. A whole v would have taken me all the way over here. And then now I need 1/3 of a u. Now 1/3 of a u is about this length that I'm marking in purple, but I don't want it here. I want it right here. So yes, this right here is like 1/3 of a u. So it's 2/3 of a v and 1/3 of a u takes me from O to S. So again, I can accept that answer. Right? It makes sense. I can accept those answers. And that was it for this classwork. Nice and easy. That was it. That was it for this classwork, guys. Simple as that. I want to do the past paper. But alright so far? Very good? No answer? No answer? Brandon, answer for them. Annalisa, answer for them.
Yes, sir.
Alright. Thanks. Alright, we could get some past papers now, right? Let's get some past papers now. So, I did send some June past papers. So, let me bring up some June past papers now. And then we're gonna, let's do some questions to the end of the class. I'm not gonna make it too long because I know you guys are easily distracted. Alright, so this is 2024. I think I sent the 2024 paper. We have to do 2024 not about 2018. I don't think I'm gonna do all of them, but let's see. I should maybe start at 2018 and work our way up. Alright, let me do this one first and then we're gonna go back and start from 2018 and work our way up. I think the more recent questions are much easier to do. Alright, so here is one. This is 2024, June 2024. So it gives us this vector PQ, and it says P is a point minus 2, 3. And I want us to find the coordinates of Q. Remember, to find the coordinates of Q, we can find a portion vector of Q, we find OQ. OQ will have the same coordinates as the point Q. Right? The vector OQ and the point Q will have the same coordinates. But because they gave us a vector, here we're going to use a vectors method to do it. Now, when they gave us this point, it's basically like they gave we automatically know the portion vector of P. Right? Because if P is a point minus 2, 3, it means that the vector OP will have the same values, minus 2, 3. And we can find OP, or we can find OQ out of this in 2 ways. Alright? Let me put this up here. So. We can find OP out of this 2 ways. I'm going to show you 2 ways to do it. One way is to think of this as a vector equation with one unknown. Why is it one unknown? Because I know the point P. I don't know the point Q. So it has one unknown. Any equation with one unknown can be solved. In vectors, you solve an unknown position vector by splitting out the displacement vector and the position vectors. So if I split this side, I'm going to write the word split. If I take this and I split it, I'm going to split up this vector, split it up into position vectors. So I split PQ into OQ minus OP. O times the last minus O times the first. Hold on, what's happening here? Right. OQ minus OP. So I'm splitting it into O times the last minus O times the first. So it's going to become OQ minus OP equals the 5 negative 7. 5 negative 4, sorry. And this is what we want to find, If we find that position vector, then we can write the coordinates. So we need to take this minus OP and transpose it on this side. So we're going to get OQ equals the 5 negative 4 plus the OP vector when it comes over. And I can put what OP is beside it. OP is just this, minus 2, 3. So OP is in this. So I can actually just do the calculation right now and write that the vector OQ is 5 minus 2 is 3, and minus 4 plus 3 is negative 1. And if the vector OQ is 3, negative 1, it therefore means that the coordinates of Q, and question asks what's the coordinates in this, so can't leave this as an answer, no, that is wrong. You write coordinates like this, like a row matrix. So it's 3, negative 1. These are your right coordinates, and so this is the answer. Not this. This is position vector. This is coordinates. Another way to do it is to say, okay, since I want to find Q, right? And I want to find OQ. Right? I want to find OQ and I have OP. And I also have PQ. So I can say P is really connecting. P is connecting the O, and P is also connecting the Q. So P is like a connecting point, like a halfway point. So to go from O to Q, what we can do is go from O to P first. From O to the intermediary point P first, like the connecting point P. And then from P, we go from P to Q. So we can do that. You can say it that way, to go from O to Q. Since P connects to O and also connects to the Q, we can go O to P first, and then plus means and then we go from the P to the Q. I get the same answer, because the OP again is just this vector. 2, negative 3, no, negative 2, 3. And the PQ is this vector that they gave us. 5, negative 4. And so this is like minus 2 plus 5, or 5 minus 2 is 3. And 3 minus 4 is negative 1. That's the vector OQ. And then because that is the position vector of Q, OQ means that the coordinates of Q has the same values, 3, negative 1. And see, that's the answer, same way, done another way. So that's 2 ways to do this question. Nice and easy. But practice these things, guys. Very easy. Alright, whichever way you prefer. Alright, the next question gives us this diagram, light vector diagrams, because you can see a way around. And it gives us some vectors. That's what it says. It says it's a pentagon and OA is parallel to DC. So OA, which is this side, is parallel to this side. So it means that 1 is a multiple of the next. Right? So this is like a fraction of A. This is like a fraction, maybe half A. Some fraction, we don't know what the fraction is. Right? But it's clearly longer. And then these two sides parallel. This is B, so this one longer, so it's a multiple of B, like KB, or like maybe 2B, or 3B, or 1.5B, right? Maybe 2B, we don't know yet, but some multiple of B, because it's clearly longer, right? And then parallel, but that's what we know. It says OA is 2 times, OD, where is OD? OD is 2 times AB, it's 2 times this. Alright, so I cannot give it away. Alright, because remember now, if you put since the direction of AB and OD is the same, we can actually add vectors to these. The direction is the same, so we can turn these into vector equations. Alright? There's a 2 times relationship. And then similarly, OA right here is parallel to DC up this way, going in the same direction, and so because this is a scalar equation, I can turn it into a vector equation by just putting on the arrows on them. Simply because the direction of O to A, same direction from B to C. Similarly, the direction from O to D, same direction from A to B, and that's why I can put on the vector component on it and turn them into vector equations. Now, remember now, what did they say? OA is A and AB is B. This is a AB right here now. It is equal to B. means then that the OD right now, is equal to 2b. So the vector down here is 2b. I'm going to put it on here so I don't forget. This vector is 2b. Let's write it beside the arrow there. And similarly, the OA is 2 times the DC. So this equation can be set up a different. Let me write it over here. So the DC becomes half of the OA. And the DC that we don't know, you know, the DC from that becomes half of the OA. And the OA is A. So this side is half of this. So I can put it on it. This side is just half of A. Because this becomes half A. That's the DC. Is half A. Right? I'm just trying to populate the diagram. Put a different color on this. This leaves better that information. So this can have all my sides. The only side I don't have is this. From B to C. But no problem. I can go from B to C. Same here because I can come around here, come down here, come across here, and then go up there. Right? It don't matter the pathway I use to go from B to C. Or vice versa. Alright? Well, that's what they want us to find now. They said, find the vector AD. In terms of the small a and the small b, the vector AD. So that's A to D. And that's pretty obvious. So from A to D, we can use, since we know the portion vector, we know the portion vector of A is OA, and the portion vector of D is OD. So we can use O times the last OD minus O times the first, which is OA. And the OD is clearly 2b minus the OA is clearly A. So we can use that as our AD. Now what else I want us to find? The vector BC. Let's look at the diagram. So we don't know portion vector of B. We said that's what I asked for, what I asked for BC. But we don't know portion vector of B. Right? So we can look at the diagram and say, how do we go from B to C? Let me do it right here. Go from B to C. You can just come around the diagram. Come here so first, come down here so, come across this and then go up here so. Keep it simple. Alright? So let's do it that way. So we're going to go from B to A. And then we're going to go from A to O. We're going to go from O to D. And then we're going to go D to C. Let's put in the values now. So the B to A is a minus B, because I go in the opposite direction to the B. So it's a minus B first. Then the A to O again is a minus A, I go in the opposite direction to the A. So that's another minus A for this one, right? And then O to D is 2B, going in the right direction now, 2B. It's a plus 2B. And then D to C, going in the right direction, is half of an A. Is half of an A. Let's consolidate the values. So it's 2B minus B is B. And then half of a minus a whole A give you minus half. I can say minus 1 plus half is minus half. So yeah, minus half A. That's his answer. B minus half A. Right? And you can check it on the diagram again. You can check this on the diagram. Let me move this out of the way and show you. You can check this on the diagram. Get into that habit. Checking your answers. Right? So this is saying do a A, do a B, and then minus a half A to go from B to C. Alright, so this is the length of a B. So I can shift this over and show you. That's a B. So that's 1B. Alright, so that's a B. Undo. I'm trying to shift it down, guys. Alright, that's a B. This is a B. Then we need a minus half A now. Minus half A. So This is a half A now. See there, that's a half A. But minus half A, we're going in this direction. So if I take this that I just marked, move it up here as a minus half A, see? It takes me to C. But this is a minus half A right now. So you see a B and a minus half A takes me from this point B to this point C. And so you know this answer is correct. Alright, so you know that answer is correct. Always get into the habit of making that good check in your diagram, especially about vector diagram. Alright, so that is from B to C. So I'm going to move this down here. It's supposed to be down here. Alright, very good. What are to that? Very good. Hello?
Yes, sir.
Alright. Next part now says, state the conclusion about AD, that's the length of AD, that means the length of AD, the length of BC, that can be drawn from your response. Let's look at it. The length of the two lines. Alright. So, we basically want to compare these two vectors now. I want to compare those two vectors right now. Right? Now, the best way to compare them is that, what that means that they're going to be parallel, right? BC, what is it again? BC and AD, right? So BC is this side and AD is this side. They're going to be parallel, but I want a relationship between the length of them. How long one is more than the next. Look like as a two-time relationship, but we have to let the calculation tell us. So we're going to compare these two vectors now, AD and the BC, right? Remember, this is the vector BC. And let the information tell us. So again, we want to basically go to the same process of what we would do to show that they are parallel. So this will be the smaller one compared to that. Because for example, this has a B, but this has a 2B. So this one is smaller. So to make this and this equal, we could multiply this one by 2. Or if we go to the first step, we'll get rid of fractions first, which will be still to multiply this one by 2 to get rid of this fraction. So if we take this second one and multiply it by a 2, I want to be able to equate something with this one. Multiply this one by a 2, right? This side becomes 2BC equals, this becomes 2B, this becomes minus A multiplied by 2. And what I find now is this and this is the same. So it means that these two things can be equated. So AD is 2 times BC. AD is 2 times BC right now, right? So based on that, we can write that AD is 2 times BC. So we write that down here first. AD is 2 times BC. Then now, if we take the modulus of both sides, because they want modulus, you know. I'm going to take the modulus of both sides and show you. Take the modulus of this side and the modulus of this side. When you take the modulus of this side, this multiplier can come to the front as a multiplier. So you get the modulus of AD, which is the length of AD is equal to 2 times the length of BC. And that's the relationship between them. See there, 1 mark for that. What state the conclusion about AD and AD that can be drawn from the responses? Right? That's what we have. But what we can do is also write it in word, because this means that the length of AD is 2 times the length of BC. AD is a longer one, 2 times. Right? AD is a longer one. This one, AD is longer than BC by 2 times as long. So you can also write that in words. AD is twice the length of BC, and they're also parallel. AD is parallel to BC. If they wanted that, you could tell them it as well. But because they put the modulus on this, it means that they're only talking about length. They're not talking about parallelism. If there was a relationship between the vector AD and BC, then you would say that they are parallel if they didn't put a modulus on these. But the modulus means that they're talking about the length of the vectors. Alright, but they're actually parallel vectors as well. But that is it, guys, for this question. But alright with that? But good?
Yes, sir.
Alright, beautiful. Alright, let's do 2023 now. 2023. I'll do the 2018. I think I gave you a 2018. We'll go on to 2018. Let's jump back and forth. Let's do 2018. 2018. Let's do 2018. That's what we have. Alright, 2018. I think it's number 11. Alright, here we go. Here we go. Alright, so we're going to start right here, 2018. So it's a similar question. June 2018. So I said, diagram below, not joint to scale shows a quadrilateral ABCD in which AB is the vector M as shown here, and DC is 3M over here. So these two sides parallel. This one is 3 times as long as that. And AD is N, the vector N. Now know that AD is going in this direction and AB is going in that direction, right? So careful now, because most times in the diagrams our direction from here is this way. This time it's going in the opposite direction there. So pay attention to these arrows. If you go in the opposite direction, you introduce a negative. It says complete the statement below on the geometric properties of the following vectors. Now, AB and AB and DC. So AB and DC are parallel, right? They are parallel, right? That's what they are. So first thing that they are parallel, because one is a mod for the next, one is M and one is 3M. So they are parallel. We're just talking about length now. The length of AD is something times the length of CD. You have to be careful. A lot of people want to put 3 times, but that is wrong, because AD, as you can see, is a shorter one. So it's not 3 times, it's 1/3. Right? It is 1/3. Length of AD is M, and the length of this side is 3M. This is 1/3 of this one. The shorter one is 1/3 of the longer one. So this is 1/3 times 1/3, not 3 times, 1/3. 1/3 times the longer one. So a lot of people would have put 3 right and got it wrong. The shorter one is 1/3 times the longer one in length. And this is talking now about the length. Once I put the modulus around the vector like that, they're talking about the length now. Alright? And this says now to express BC in terms of M and N. So look at the diagram and see over from B to C. She can't come across here because we don't know that road yet. We have to go along the vector direction that we know. So it's simple. We're going to come back here with the minus M, come down here with the N, and then go across here with the 3M. Simple as that. I don't have to put in it, make it complicated. Keep it simple. Keeping it simple, we can say going from B to C equals, come back here with a minus M first. That's minus M. That's this part. Because going in the opposite direction is minus M. Then come down here, same direction as the N. That's a plus N. And you're going straight across here with a plus 3M. Plus 3M. And then you consolidate. The 3M and the minus M is 2M. Plus this N. And that is the answer. 2M plus N. And we can show it on the diagram as well, that this is true. Let me copy this down. 2M plus N. See it here? So look at this now. Look at this now. This is 1M now. Let me draw it in a different color. This is 1M. We need 2 of them. Let me move 2 of them. This is 1 of it. I'm going to copy it, draw another one and move it again. That is 1 of it. I'll copy it. I'm going to copy it and put another one. That's 1 of it, right? And this is the second one. That's 2 M's now. M and N. Right? So this is M, this is a M, and another M. That makes 2M. Then I need a N. So this is a N now. This is a whole N coming down here. Right? That's an N. So if I take this and move it over here, there, that's an N. It's not so 100% accurate, but you get the picture. Because I didn't join up everything, but you see it. Right? That 2 M's, this is the N, you know. 2 M's, M plus M, that's 2 M's plus a N takes it from B to C. So you see, you can accept this calculation. That's just a quick check. You can accept that calculation. And that is it. Alright? That is it. Let me take these off now. Practice to check your answers this way, guys. Alright, down here now, it says L is the midpoint of CD. Right? L is the midpoint of CD. Let's look at it. CD. So this is the midpoint. Now, if the whole thing here so is 3M, it means that right here, from this to this, is 3 over 2 M. And from here to here is also 3 over 2 M. Half of 3M is 3 over 2. Right? The whole thing is 3M across, you know. And this is the midpoint. So it means that this single piece right here, so it's 3 over 2M to here. And then this single piece right here, so is another 3 over 2M. Half of 3M is 3 over 2M. Alright? Because L is the midpoint. What vector do I want us to find? I want us to find the vector BL. So we can look at the diagram again and do a similar thing. BL. How do we go from B to L? Easy. Come back here again. Come down here. And then go across here. And use a different color and show you. And do same thing. Come across here. Come down here and then go there. Or, because okay, since we now know the BC is 2M plus N. Can we know this now? We work it out now. See it here? It's 2M plus N. We can also come down here with the BC and then go back here so to reach L with the minus 3 over 2M. Your choice, it doesn't matter. Right? But I think most persons would prefer to just stay on these pathways and just come here so first, come down here and then go there so same difference you're gonna end up with. Alright, so if I do it now, so going from B to L, I can come across here first with a minus M again, minus M. Come down here so next with a N plus N, and then go across here so with a 3 over 2 is a 1.5 M plus a 1.5 M or 3 over 2 M. If you consolidate, that's the only N in there, N. Then this is 1.5 M minus 1 M, minus M. 1.5 minus 1 is half. So I'm going to write plus half M. So it's N plus half M. I'm underline these vector components. Underline these. Alright? So we can check this answer as well. Check if you go from B to L is a N and a half M. Let's check it. Let's check it. Let's check it. Let me take these off and check if this answer is correct. Alright? N plus half N. So the N is going to be starting here. The N is going to be a line parallel to this. It's down in red. Same length as this coming down and parallel to it, right? That's a N. I'm gonna move this N right here. That's a N. So put it right here. So this right now is a N. Then there are half M. So see a whole M here. Half of it is about this. That's about a half M. So if I move this now, and add it to the end of the N, you get it there. Not 100% accurate, but you see it. N n and half m takes me from B to L. So again, you can accept that answer. See, remember the diagram is not drawn to scale, you know. So, you know, it's not so 100% accurate, but you get the picture. Yeah, you get the picture. Hold on, guys, my battery is running out. Give me a second, guys. I have a plug in my battery on my phone for this thing run out of power. Give me a second, guys. 1 second. But this finishes this question, though. This finishes this question. I just don't want to run out of battery. Alright, so we just got it up here. This calculation. Hold us still. Let's see if I can get some of the charger phone. Just copy it down here. Cut and paste. Down here. That is it. Give me a second. I'll get a charger, plug my phone before it runs out. It got fast. Right. Alright, very good. But alright, students. Alright, let's jump back to 2023 now, right? So we're going up and down. No, recent and late. So let's look at 2023. 2023. Let's see what we get. It would be good if you guys go and redo these questions, you know. Redo them, do them over again. If you did it, I didn't get it right, you made a mistake, you're going to do it again. If you never do it at all, you're going to do it now. Alright? Alright, let's part C on this one. Alright, let's see what this one says. 2023. Alright, this one says the following vectors are defined as shown below. So you have a vector wx, you have a vector xy, you have a vector zy. They didn't give us any diagram, right? So we have to be smart now. Remember, vectors about going from point to point. If you want, you can actually kind of put on some points if you want, right? So you can put on some points w, x, y, and just put on some of this information on it so you can see how we are on. But let's just work with what we have. It says determine each of the following. It says other than 5, negative 1, we want to write a vector that is parallel to double x. A vector that is parallel to double x is a vector that's a multiple of double x. So any multiple of double x will work. So for example, I can just write 2 times double x, which will be 2 times this, which will be 10 negative 2. That is it. A vector that is parallel to double x is a multiple of double x. Right, that to get the answer. But understand that, or 3 times, or even half of it. But I think most people will just write 2 times it. That is it. Done. Much marks for that. 1 mark for that. But understand that, a vector that is parallel to double x is a vector that is a multiple of double x. And that is it. Alright? Simple as that. Alright, anything else? Next question wants wy. I want to go from wy. Alright. To go from wy, right? So looking at what we have w right here, and we have y right here, and we also have y right here. What you want to look is which letter, which point is connecting the w and the y. clearly the x is connecting the w and the y. Right? The x is connected to the w and the y. So obviously then, to go from w to y, we can go w to x first with this vector and then go x to y with that one. We can go w to x and then go x to y. W to x and then x to y. So the w to x is clearly 5, negative 1 plus the x to y is negative 3, 7. Right? Negative 3, 7. So this then works out to be 5 minus 3 is 2 and minus 1 and 7. Same as 7 minus 1 is 6. That is it. Simple as that. But understand that? But good at that?
Yes,
But
sir.
and then now we want to go from x to z. Alright, we want to go from x to z. So we want to see how we can connect x to the z, right? Which point is connecting the x to the z? Because to go from x to z, we want to go x to somewhere first and then go from that somewhere to the z. Alright, let's look at it now. So alright, x. So see it here, x is connected to the y and z is also connected to the y. Right? We want to go x to z, you know, and they are both connected with a y. So ideally, you will go x to y first, and then go from the y to the z. That's how we can go from x to z. Because y is connecting the x and also connecting the z based on what we have. See here? Right? X connects to the y, and the z also connects to the y. So y is like an intermediate point, just like they gave us yz. They'll give us zy instead of yz when it's really yz we want down here. But simple. If this, hold on, if this is zy, it means that yz is just the negative. You reverse it. It's just a negative zy, you know. That's what yz is, you know. So this can just reverse this, just put a negative on this, just negate that, so it becomes minus 8, 7. So you negate that, it becomes a minus 8, and negate that becomes a 7. So this is your yz, right? Which is what you want. So it's basically then this vector, let me make it see on the screen, this vector is your xy, which is negative 3, 7, negative 3, 7, and your yz becomes negative 8, 7, negative 8, 7. That will take you from x to z. And you work this out. Negative 3 and negative 8 is negative 11. 7 and 7 is 14. And basically, that is it. What of them is 7? Yes, 7, 7. That is it. That's the answer right there. What good? What okay?
Yeah.
Beautiful. Simple as that. Hold on a second, guys. Hold on a second. Hold on a second, guys. Hold on a second, guys. Alright, so about that, guys. Sorry about that. Alright, so that finishes this question. Oh, they want the modulus of xy now. Alright, modulus of xy. What is xy again? Xy is this vector. So I want the modulus of this vector now. So xy is negative 3, 7. And I want the modulus of it. Let me just copy it down. Copy this down here. And I want the modulus of this vector now. Modulus is easy, guys. It's just basically equal now to the square root of this value squared and this value squared. Simple as that. Right? And you don't even need to put a negative on that. Because what this means, remember what this means, xy, is that to go from x, if x is this point, I want to reach y. This 3 means you got 3 units to the left. 3 units this way. That's a negative 3. And this 7 means 7 units upwards. And y will be right here relative to x. And you're trying to find the length of this side. This is the modulus. The length of this side is the modulus of xy. Pythagoras theorem says that this side is the square root of this side squared plus this side squared. But this side is really 3 in length, you know. The negative is just direction, you know. So it's really 3 squared plus 7 squared. That's why I say you don't need a negative on this. That's what is happening. Right? I just want you to have a clear understanding of this formula. So whatever this works out to is the answer. This is 49 plus 9. 49 plus 9. So it's the square root of what? 58. I write already units beside it. I can leave it like that. Right? 49 plus 9 is 58. That is it. Alright, that's it. That finishes that question. Very good? Are you okay?
Yes, sir.
Alright. Alright, so that's 2020. Let's go to 2019 now. 2019. 2019. Right here. Let's go to 2019. So you see the vector is easy, guys. It's easy. You can do it in the class and understand it in the class. You can do it in the exam. Right? You just need to practice it. It's very easy. It's basically just how you go from point to point. Right? That's what it is really at this level for the most part. Right? How you go from point to point. This question now, it says relative to an origin O, portion vector of point A is 0, is 9, 0. So if the vector is 9, 0, means that the point is 9, 0, you know. Just like coordinate geometry is like it from the origin here is like it over here, so 9 units over there, so that's what it is, see there? 9 across there, so right? And this is the origin, you know. Just that they don't put the y-axis and the x-axis, but it's like we have a y-axis and the x-axis here. So like this would be a y-axis and this would be an x-axis. Right? And this point is 9, 0, so it's right on the x-axis. And then this point, portion vector B is 3, 6, so that's the point 3, 6. It's 3 this way, 6 up that way, 3, 6. Right? Just keep it in simple terms. And it says D and E are on AB and BC. AB are on AB and OA, respectively. So D is on this line, right? And and E is on this line, as you can see. Let me take out these markings. Take these off. Right? So they're giving us these 2 points. And as such that AD is 1/3 of AB, right? So AD is 1/3 of AB. Good, that's a 1/3, all right? So we remember that, that's 1/3. And and so if this is 1/3, then up here, so it's 2/3 of the full line, right? And then similarly, if this is 1/3, then from here to here, it's 2/3. And this one easy to, because if this whole length is 9 units, and this is 1/3, 1/3 of 9 is 3. So it means right here, so it's 3 units. At this point, therefore, is 9, 0, you know. not 90, 30 and 1/3. 30 and 1/3 of this whole length. This whole length is 9 across. So this point is 30. So if this point is 36, it means that this is right under here, so you know. This is 36 and this is 30. And Mr. Up here, so it's 6 units up that way, you know. So the thing is quite simple and straightforward, guys. It's simple, not complicated. So right here, so it's 30 right now. Right? So the vector OE is, even if you put on the equation, OE is 1/3 of OA, where the OA is 90. So it becomes 30. As I said, that's what the OE is. So it's really straightforward, really simple and straightforward. Alright, I know that this side, as I said, is 1/3 of the whole thing. Alright, let's work with information now. What do I want us to find? Alright, it's simple information. What do I want us to find? I want us to find the vector AB. And it's always easy when you know the portion vector of the A and know the portion vector of the B. This becomes OB minus OA. Because you know the two portion vectors. The OB is this one, 3, 6. And the OA is this one, 9, 0. This works out to be negative 6, 6. You can see it on the diagram. To go from A to B, we come back 6 this way, negative 6. And then we'll go up 6. Negative 6, 6. Makes sense, right? So you come back to E and then go straight up. Because the E is directly under the B. So this answer is correct. Alright, next one. We want OD. Let's put the diagram. OD. So we want to know over from O to D. Right? So what we can do, so we can say this way. To go from O to D, we're going to come out to here first. We'll just calculate AB now. Just calculate AB now, guys. So it's as if we can travel along this side now. Right? And we know the AB now is minus 6, 6. And this is also 1/3 of it. So it means that AD is 1/3 of this. Right? 1/3 of that. So we can put it. The AD is 1/3 of the AB. 1/3 of this is negative 2, 2. 1/3 means that you divide each of these values by 3. So to go from O to D, you're going to come out to the A first using the OA, which is a 9, 0. And you're going to add now the AD, which is a minus 2, 2. Minus 2, 2. You're adding those two. 9, 0 and minus 2, 2. It's simple. Alright? Well, let's put a format for doing it. So to go from O to D, we're going to go O to A and then A to D. The O to A is 0, 9, no, not 0, 9, 9, 0. And we just worked out the AD a while ago at minus 2, 2. So I'm leaving this on the paper, this AD. I put AD, it should be AD. Somebody couldn't tell me I have AD is AD. AD. 1/3 of the AB. Minus 2, 2. Alright, so let's work out to? Let's work out to 7, 2. 7, 2. And we can check it. This is saying to go from O to D. We must come 7 out here, so. And then go 2 straight up. See, that is 7, 2, you know. 7, 2. This is from O to D. Means that this point D has coordinate 7, 2. Because if the portion vector is 7, 2, that's OD in a portion vector of D. It means that D is a point 7, 2 with the same values. You know, on the vector BE, let's look at the diagram now, the vector BE. So BE, easy, is basically negative 6, you know. Is no horizontal is 0, negative 6. I come straight down. But if you don't know, we can say, okay, I'm going from B to E. We can use this point as OE. If you know that OE is 3, 0. And OB is 3, 6 right here. You can subtract these two. Right? Let me copy them down. It's just 0, negative 6 is the answer from the diagram. Copy and paste it down here. So this question very easy. So this vector is OE minus OB. If using O time the last minus O time the first. Move this out somewhere. Put under here. Right, the OE is 3, 0. Minus the OB is 3, 6. 3 minus 3 is 0. 0 minus 6 is negative 6. See there? That's 6 down, done. So this question was really very easy. 2019. Alright, but good?
Sir.
But okay?
Yes, sir.
So, yeah, we're going to do one more, or at least maybe one more. So let's do 2022. Let's do 2022 now. 2022. More maths equals better maths. 2022. So 2022 and 2021 I never finish. 2022 and 2021 I never done. So I'm gonna do, guys, I'm gonna send a worksheet to the group for our vision. I want you guys to follow the instructions of what questions to do and send to the group. Alright, follow the instructions. Alright, so 2022 question here, you know. That's what this one says. I'm gonna do 2021. There was no June paper in 2020 to do, so that's it. Alright, this one says in the diagram below, O is the origin, OX is U. This vector right here is U. That's from here to here is just U. And OY is V, so this is vector V right here. It says OX and OY are extended so that X and Y are midpoints of OA and OB respectively. So if this is the midpoint of this side, it means that the vector from here to here, this length and this length is the same. So it means that the vector out here is also V. This is another V. Write it properly. That's another V. So everything out here so is 2V. Alright? And up here is another U, like this. So it means that the total vector up here so is 2U. It's quite simple. So you know all those position vectors so far. You know this, you know that, you know this, you know that. You have all those position vectors so you can find anything. You want the vector BX. That's from here to here. So the diagram is showing, you know, you could go minus 2V plus U. Minus 2V can go in the opposite direction plus U. Or it can be U minus 2V. As it would be a U up this way. That's a U. And a minus 2V takes you back here. Alright? So, anyway you want to look at it, that's going to be the answer. We can use O times the last minus O times the first to do it. About those position vectors. So BX is OX minus OB. O times the last minus O times the first. So the OX is this U right here. And the OB is 2V. 2V, all of that is 2V, so minus 2V. So you see, 3 ways I look at it, that is the answer. Anyway you want to look at it. Hold on a second, guys. Hello? Yeah? Yeah, I'm in our class. What's up? Alright, we can talk about it later. Because I'm in a class now. Yeah. All right. Next one. Given that YA and BX intersect at M and BM is 2mx. So BM is 2mx, right? So BM has 2mx in it. Express BM in terms of U and V. Let's look at what they said. They said YA and BX intersect at M. Let's put on a diagram. So diagram will help us. So which two lines I said? YA and BX. YA, which is this, YA and BX, which is this is BX. They intersect at M right here. And what they said about the length now, they said BM is 2mx right up here. So BM is 2mx. All right. So this side has 2 of this in it. So if you put it on the diagram again, BM, this length BM, 2mx, and this is an mx by itself. This is 1mx. So we take off the arm, take off the mx, and focus on the numbers. It's a 2-to-1 ratio. So it means then that this side, this length, sorry, is 2/3 of 2/3 of the entire length up here, and this piece inside here is 1/3 of the entire length. Remember, we know bx, we know bx, right? We know bx. So this piece is 2/3 of bx as bm, and mx is 1/3 of bx. We can travel along this line if we want, because we know the vector. We can travel the entire way using the bx, or we can go 2/3 from b to m, or we can go 1/3 from m to x of this vector bx. That must be the chain of thought. All right, that's what I want us to find. I want us to find bm in terms of u and v. Let's look at it. Bm. So bm is just 2/3 of bx, as you can see, 2/3. All right, so let's write that. Bm is just 2/3 of bx. What was the bx again? Let me copy that down. The bx is this. I will do 2/3 of it. This is the bx. All right, copy. All right, here. Let's put it here. So bx is this. I'll just figure out that the bm, based on information, is simply 2/3 of the bx, which becomes 2/3 of this. So it's 2/3 of this part, which is 2/3 of u, and then 2/3 of this. You want to multiply this by 2/3, it becomes 4/3. So it becomes minus 4/3v. That's the bm right now. 2/3 u minus 4/3. 4/3 is 1 1/3 v. And we can check this on the diagram if you want, Let me copy it up on the diagram and check it. If this makes sense. Let's go up, copy it and check it. Let's copy it and check it on the diagram, right? Let me put it right here. Let me put it up here, and then we're gonna check if it makes sense. It's always nice when you can check if you answer. So this is going to go from B to M with a different color, purple. Go from B to M must go 2/3 of a U. See a whole U here now, 2/3 of it. So 2/3 of a U would be about maybe this length. So I'll copy this over here. So that's about 2/3 of a U. This. And then we must go minus 4/3. No, 4/3 is minus 1 1/3, Minus 1 1/3 V. So we're actually going longer than a V. Alright? So this is a V. That's a V. And a third V is about this. So we're going 1 1/3. So this is 1 1/3. But we have to go in the opposite direction. Like I said, minus. So I'm going to combine these two. So I'm going to take up this one first. This is a -1. That's a -1. Then I need another third. Sit here, another third. See that? That's correct. So you can accept this answer. This is a 2/3 u, and this is a minus 1v and a minus a third v. These combine to minus 4/3v, which is minus 1 1/3. So the diagram and my calculations match. I can accept that answer. All right, I can accept that answer. Everybody see this thing, one practice it, and get the answers in vectors. Check if it makes sense. All right, diagram and calculation must match. You know that this answer is correct. All right. Next part now says, using a vectors method, show that the ratio ym to ya is 1 to 3. 1 to 3. So to do that, we need the vector ym and the vector ya, and we want to get the distance out of them. So ym and ya. So let's look what ym is first. The vector y, because I say use a vectors method, so we use the vectors, right? What is ym again? Let's look at the diagram. What is ym? What is ym? So ym, what a question, crazy. Ym to ya. Alright, so the ym, we're gonna have to come here. I have to come here and then do the bx. So it's gonna be yb plus bm. That goes from y to m. Let's write it out. So the ym is yb plus bm, and the yb is just v. The yb is just this v, and the bm is this vector up here. That's the bm. So adding that to it. Need some more space. I just want to do it on the screen where the information is put over here. Put up here and then I move it down. So I'm adding now this bm, which is this. So that is 2/3 u minus 4/3v. I'm copy this down now. That's the ym part. Alright, this question requires a little bit more work than normal, but don't matter. It's 3 marks for this, so it requires some effort. So this is our ym right now. And as usual, I want to consolidate the values. Now, this is a whole v minus 1 1/3 v. It's like 3/3. I want them to have the same denominator. So 3 minus 4 is -1. So it works out to be 2/3u, and then 3 minus 4 is -1, minus 1/3v. Or you could say a whole v minus 1 1/3. So you subtract the 1 and you subtract another third. That's why you have minus 1/3 v as a result. But this is your ym right now. And you now need ya. So we're gonna look and see how we can find ya. So we have to calculate ym, but let's see if we can just figure out ya. Which we can, because I think we know the portion vector of the a and y. So let's calculate ya up here. We can look at it. Go from y to a. If you look at it, it is minus v plus 2u. See? To go from y to a, it is minus v plus 2u based on this diagram. So ya, based on the diagram, y to a is minus this v down here coming back, and then I could use O time the last minus O time the first, as well. Ya is OA minus OY. O time the last minus O time the first. The OA is this 2u right here, minus, and the OY is this v. So it's 2u minus v. That is 2 better. So I'm going to copy this down. And not writing so good together, guys. The pen not writing so good. So that's my ya. Put it down here. That's the ya it's using now. Ya. Paste. paste. Right. So then now we have these two vectors to compare, right? This is the YA. So this is the only one with the fraction in it. So we have to get rid of the fraction of this one first by multiplying through by 3. Right, so multiply 2 by 3. Multiply this side by 3 first. You will get 3ym equals, this become 2u. 2u become minus v, which is the same as this. And so you can equate these two things. These are different color now. You can equate these two things. Equate. I told them equal the same thing. So you can write that YA, or you can write that YM. No, 3YM, sorry. Is equal to YA. Why did I put it in that order? Because I put the YM before the YA on this proof. Alright? So the 3YM is equal to the YA because both of them equal 2u minus v. And then from here now, we'll just take the modulus of both sides. So that the modulus of 3ym equals the modulus of YA. So we can get rid of the vector out of it. It becomes 3ym without the vector equals YA. And then to form a fraction now, you divide this and divide the 3. Right? So I'll divide this side, both sides by divide the 3 under here, divide the YA under here. Right? So you're gonna get the YM over YA equals 1 over 3. So the ratio is 1 to 3. And this means then that the YM to YA is 1 to 3. And that is shown. Question like this you want to redo, guys. A nice question. You want to redo it. You learn a lot from this question. Alright? You want to redo a question like this. Do it over again. Watch over the video. Work it over again. Alright? So one more question. Body good? Body alright? Body good?
Yes, sir.
Not
Yes,
doing
sir.
anything different from what we do in class, guys. Right? Just that some questions require like a bit more activity than others, but no problem. It's the same thing that we're doing. Same thing we're doing. Alright? Same thing we're doing. Alright, let me put this 3 over 3 in red. Because I introduced it to get the fraction. So let me put it in red. It's 3 over 3. Put it in red. If I told just V first, I'll put it 3 over 3. So I could work it with this one. Alright, and the denominators are the same. We basically just focus on the numerator. 3 minus 4 to get this negative 1 over 3. So put that part in red. Alright, let's look at 2021 and we'll call it a D. 2021. So in a sense we get so close to it and I'll just finish it. In a sense. That 2021. Let's just finish it. Let's just finish the job. Alright, more maths equals better maths and I will practice a lot. Alright, 2021. This is the vectors down here. Alright, let's see what this one says. We have class on Wednesday. I'm gonna send some work in the group for you to do. Alright? Wednesday and Thursday. Everybody. This question says the diagram below shows triangle OAB in which OA is a vector R. So you see this R is the entire vector up here and not OC. So be careful of that, right? The entire thing. I don't like that I put the R right here in this diagram. It's kind of ambiguous. And then OB is S. All of this vector is S. If I'm in the exam, I'm going to make a note that this is not from here to here. It's the entire thing, right? Then it says OC is 3/4 of OA. So you see, I prefer to make that change. This is just 3/4 of the entire thing. So I will come on the exam and say, okay, I will change this and mark it out. If I'm in the exam room, I'm going to mark this out. So I don't want my diagram to throw me. So I'm going to mark this out. I'm going to mark out this arrow on my exam paper. I'm telling you what I would do because I don't want the diagram to throw me off. And I'll put on the vector like this. Right here is 3/4 of the R. The entire thing is R now, and this side is 3/4. And that is 3/4, then from here to here is just 1/4 of R. 1/4 of the R. So this is 3/4 R and this is 1/4 R. So that 3/4 and 1/4 make a whole R up there. Alright. Then they said AD is 2/3. 2/3 of AD. So AB, let's go again. AD is 2/3 of that whole length. So if what's a third? So this is 2/3. And from here to here is 1/3. Alright, they like to work in thirds. Quarter sometimes, or half, midpoint. Alright, and I said E is the midpoint of this side. So E is the midpoint of this side. Alright. Alright, E is the midpoint of that side. That's what I want us to know. It says, right, in terms of R and S, a simple expression, simplest form expression for CD. So I want a vector for CD. Now the thing about CD, we can't use O time last minus O time the first. Because we don't know OD. We know OC now, but we don't know OD. So we can't use that. So we're going to have to depend on the diagram. So the diagram to go from C to D. This guy will come up to here first. This is the diagram. We'll come up to here first using that, and we'll go from A to D. The problem is that we don't know AD yet. We know so the AD is 2/3 of the AD. But we never ask us for AB. But to find the AD, we need to find 2/3 of AB. So we're going to have to find the AB, even though they did not ask for it. So let's work out the AB over on the side so we can use it. And not every question I'm going to ask for everything that you need. Sometimes you have to decide that you're going to need something and work it out. So we work out AB up here. And we can work out AB from this because we know the position vector, so we can put it up here. AB is simply OB minus OA. So it is this one minus this one, S minus R. And so this AD is 2/3 of that. I'll just put on the diagram since we're here. Let's just put it on there. This vector here is 2/3 of the AB. That's what the AD is. So it's 2/3 of this. So it becomes 2/3 S minus 2/3 R. That's what the vector from A to D is. And so now we can find CD combining this and this. Easy. Alright, and I can leave this working out on the diagram. So my CD is therefore equal to, working out my diagram, it becomes C to A plus A to B, which becomes 1/4 R plus, and I will put in this now, 2/3 S minus 2/3 R. Then I have to consolidate these two R terms. I have to put on, this is the only S term, so I'm writing that first, 2/3 S. Now I need to do 1/4 minus 2/3. Let's look at it, 1/4 minus 2/3. Now this one I can put multiply by 3/3. Multiply that one by 3/3. and multiply this one by 4/4. And the lowest common multiple of the 3 and the 4 is 12. 4/4. So then this works out to be 3/12 minus 8/12. And then 3 minus 8 is negative 5. So this one is become negative 5/12. Negative 5/12 R. That is it. Don't be afraid of these fractions, guys. Just work them. Alright, if you put this in a quarter minus 2/3, you're going to get minus 5/12 anyway. But that is it. Alright, and if you want, you can check this again, but I'm not going to bother do it this time. You see how to check it now. I know it is correct. Alright, I can just do a rough check. 2/3 of a S. See a whole S here, so 2/3 of a S will be maybe this length. 2/3 of a S. Okay, I'll move this up there. And this is 5/12R. That's less than a half. 6/12 will be a R with a half. 5/12 is less than a half. Right? So this is a whole R. This is a whole R. Half of a R be about here. So you see, that looks like half of a R for 2 or 5/12R. This is like 5/12R in the opposite direction. So I can accept this answer. Right? I can accept that answer. So you can do like a rough check, make sure your answer is correct, which make sure it makes sense. Alright, so that is correct. Next part wants OE. Let's look at the diagram. OE. So I want to go here now. Now OE, to go from O to E. Remember, I know we know CD now, we know CD, guys. Don't be afraid of it. We know CD now. So we can travel along this line using this vector now. So look at it now. To go from O to E, we're gonna come up to the O to the C first and then go CE, which is just half of the CD. Right? So we can literally write that OE is equal to O to C and then half of CD, because CE is half of CD. So the O to C is clearly 3/4R. This is 3/4R. And then we're doing half of this, half of that. Now half of 2/3 is 1/3. So it's 1/3 S. And then half of 5/12 is 5/24. Half times 5/12 becomes 5/24. Don't be afraid of it. So subtracting 5/24R. So I have this R term and this R term to consolidate. This is the only S term. Just going to put 1/3 S. And then this and this I have to work out now. So it's 3/4 minus 5/24. Need to multiply this by 6 to get the same denominator as that. So I'm going to multiply this one by 6/6. 6 3s are 18/24 minus 5/24. 18 minus 5 is 13. So it becomes 13/24. So this becomes plus 13/24 R. Alright? And 13/24 is a little more than half, because 12/24 that be a half, right? So we can still check this answer. So we need about a third of a S and about a half of a R to go from O to E. Let's check it. So we need a third of a S. So starting here to here, let's check it. Third of a S. So this is about 3/3. A third of a S will be about here. And then this is a whole R. Remember, you know, this thing is a little bit more than a half. Half of R will be about this. You see there? That's about the same length as this. A little bit more than half. So you can accept this answer. 1/3 S. And this is now 13/24, which is a little bit more than half of a R. You can accept that answer. Go from O to S, O to E. So you get the answer like this, and you know, so you're right. This is correct. You can accept it. Alright, anything else on this question? Wow, that question lengthy. Another part down here. It says O, Q, and R have coordinates. 0, 0 is the O, 5, 2 is the Q, right here, 5, 2. And the R is minus 1, 4. That's what I want us to do. I want the vector OR. Easy. If R is the point, minus 1, 4, then OR don't need no calculation. OR would have the same values, minus 1, 4. Okay, write OQ for good measure. Q is a point, 5, 2. So OQ will have the same values, 5, 2. Like that, right? But this is the answer that I want for this one. 1 mark for that. We only want the modulus of QR. Now we can get the modulus of QR two ways, you know. You can work out what QR is first, right? And then calculate the modulus. For the length of QR, you can work it from the diagram. Using Pythagoras' theorem, just look at what vector takes you from Q to R. You can look at the diagram. Q to R from the diagram. You can look at it, you know, you have to calculate, you know. You can count it off. Q to R. It's called the coordinates. Now, first thing you have to realize that every 2 grid is 1. See that? That's 1 unit. Between 4 and 5. That's horizontal. The same thing vertically. Between 2 and 3 is 2 grids. So 2 grid is 1 unit, right? So if you're counting off from Q to R on the diagram to get the vector, it's 1, 2, 3, 4, 5, 6 to the left. It's minus 6. And then 1, 2, 2 upwards. Means that the vector QR on this diagram is minus 6, 2, you know. Quick and fast, you know. And so the modulus of QR using Pythagoras' theorem. This is the vector QR, you know. This is the line QR, and you want to find the length. Pythagoras' theorem says that this length, because that's a right angle triangle now, is the square root of this side square, which is 6 squared, plus this side square, which is 2 squared, you know. 36 and 4 is 40. That becomes the square root of 40 units. Quick and fast. Right? That's what it will be down here. Right? If you use Pythagoras' theorem, quick and fast like that. Square root of 6 squared and 2 squared. That's from the diagram. But let's say you don't want to work from the diagram. You can also calculate it using your vectors method. Right? So let's say you want to find the vector QR first. Using a vector method. We just work from the diagram and I say it's square root of 40, you know. Units, you know. But let's say you don't want to use a diagram. The diagram is quicker to do. I can count off the units, right? Alright, but let's say we're going to use a calculation method. So the vector QR will be OR minus OQ. O times the last minus O times the first. What is OR again? The OR is minus 1, 4. Minus the OQ was what again? 5, 2, right? 5, 2. 5, 2. If you work this out, you're going to get minus 1 and minus 5 is negative 6. And 4 minus 2 is 2. Same vector I got up there while I go minus 6, 2. See there? By counting the grid. Minus 6, 2. Minus 6, 2. Then you calculate the modulus the same way. Modulus of QR will be the square root of this for the square. You don't have to put the negative on it. Because negative 6 squared and positive 6 squared is the same 6 squared plus 2 squared. This becomes 36 and 4 is 40. Square root of 40 units. But as you could see, we could work it off on the diagram quick and fast. And that is that for today, guys. Nice session. We have a good number of questions, so hopefully you guys will go and redo these questions and keep practicing. I'm going to send a revision worksheet into the group. I think I sent it from this evening. I'm going to send the video first and give you some time to go back through the video, redo the questions that you did not get right or the questions you did not do. Alright? And we'll come back to class on Wednesday and Thursday. It's straight revision. Straight revision. And I'm not repeating what I'm doing on Thursday. So you have to come to class Wednesday and Thursday. Not one or the other.
Yes, sir.
Come class Sunday, it is Sunday and Monday, both days. I will revise it. I want to get a good amount of work done in the revision. So I'm going to send a worksheet and you'll do the questions on the worksheet for revision purposes. But go back through this for me today, please. I'll give you some time to go back through it and redo the questions you did not get right or the questions you did not do. Alright, so see you all on Wednesday, guys. Bye. Bye, everybody.
Bye.